Okay, in this last video, we're going to talk about two things. We're going to talk about how to start with zeros. And so if I say that x equals -1, 5, and -2 as zeros, how can I get to a polynomial? And we're going to talk about multiplicity components. And I'll kind of get to that a little bit more in a minute. And so let's think about this. If x equals -1, and I want to call that a 0, that means what is my factor going to be when x equals 0? So let's make this side equal to 0. I'm going to add 1 to each side. And so this factor would be x plus 1 equals 0. And so you can basically do that for all of them. Not even basically, that's what you're going to do. So we have x plus 1 equals 0. We have x minus 5 equals 0. And we have x plus 2 equals 0. And so these are our factors. And we know that these are factors because we're just doing the reverse of what we did earlier. Before, we took a polynomial, factored it, got these factors, set them equal to 0 to get our x-intercepts, or our zeros. And so now we're going to start with zeros and make a polynomial. So now we just have to distribute. What I recommend doing is picking two parentheses and starting there. So x times x times x is x squared. X times -5 is -5x. 1 times x is positive 1x. And 1 times -5 is -5. And we can simplify that to just be x squared minus 4x minus 5. And now we're going to bring down this factor and distribute again. So now we have to go x squared times x will give me x cubed. X squared times 2 will give me 2x squared. And -4x times x is -4x squared. And -4x times 2 is a -8x. -5 times x is -5x. And then -5 times 2 is -10. And we simplify where we can. We get x cubed minus 2x squared and -4x squared become -2x squared. And -8x and -5x become -13x. And then -10. And so that is our final answer. That's the polynomial. Let me try that again. That's the polynomial that would factor to give me these zeros. Pretty cool, huh? Let's try this one over here. There are 4 zeros. Oh man, look out. So let's do that. Let's make our factors. If we set x equals 4 and we solve for 0, we'd have to subtract 4 from each side. So we get x minus 4 equals 0, x minus 2 equals 0, x plus 3 equals 0, and x equals 0. So we just have an x. Get these all on the same field here. And you can see, if you're ever curious to whether you're doing these correctly or not, you can take these factors that you've written, set each factor equal to 0, and make sure you get these numbers. X equals 0, x plus 3 equals 0, give me x equals -3, give me 2, give me 4. Great. So now we can do two at the same time. We'll do these two to make a binomial, and then, or a quadratic expression, and then we'll do these two to give me a quadratic expression, and then we'll multiply them by each other at the end. So, whoa, why did it go up there? So let's check it out. X times x is x squared. And x times -2 is -2x. And -4 times x is -4x. And -4 times 2 is +8. And so we have that one. And then over here we have x times x is x squared. And 3 times x is 3x. And that, of course, this can simplify. Negative 2 plus negative 4 will give me negative 6x. So now I have these two. Let me go ahead and put parentheses around them to make it easier. And we're going to go ahead and distribute those out. So x squared times x squared is x to the fourth. X squared times 3x is 3x cubed. Negative 6x times x squared is negative 6x cubed. Negative 6 times 3x is negative 18x squared. 8 times x squared is 8x squared. And 8 times 3x is 24x. And so now we can simplify where we can. X to the fourth doesn't simplify with anything. 3x cubed minus 6x cubed is negative 3x cubed. Negative 18x squared plus 8x squared is negative 10x squared. 10x squared. And then we have 24x. And so that is the answer. If we tried to factor this, we would get these four factors right here. And so you've got to be able to do that too. You've got to be able to start with zeros, formulate factors, distribute the factors out to get you a polynomial. So what the heck was that last thing I was talking about when I said multiplicity of factors? Well, what that means is if you have multiple zeros, you can analyze how many of one factor you have. So let's say that I factor a polynomial and I get x plus 3, x plus 3, and x minus 1. Let's see, these are the three factors I get. If we set those factors equal to 0, we'll see that I get x equals negative 3 and x equals 1. And so because this has two factors, or x plus 3 occurs 2 times, that means it has a multiplicity of 2. I'm just going to go ahead and write it. That means the 0, negative 3, has a multiplicity of 2. And the 0, x equals negative 1, well, there's only one of those, so it has a multiplicity of, what am I doing wrong? Oh, right there, of 1. And so what this does is these numbers of zeros tell us how a graph acts at that point in time. So where it crosses negative 3, it's acting like a polynomial with a degree of 2. And what are the degrees of 2 called? Quadratics. So it is acting in a more quadratic fashion at the spot x equals negative 3. Since we have a multiplicity of 1 right here, that means it has a degree of 1. It's acting in a more linear fashion at that point in time. And so why this is important is if you go back to our last video where I was talking about relative minimums and relative maximums and using end behavior, we can analyze the amount of zeros that there are as well, and use this to help us figure out if, what our graph will look like at various points. And so what I mean by that, in a general sense, and we'll do more with this when I get back. So if you struggle with this last part, just don't worry about it. We'll touch on it when we get back. But we know that we're going to cross at negative 3, 1, 2, 3. And we know that we're going to cross at 1, which is over here. And if you can see this, x times x times x is going to give me x cubed. And it's going to be positive. So it means the right side is going to end positively and the left side is going to go opposite of that, which is down. We're going to have a maximum of 2 turning points, and we could plug in some numbers in here to figure out where exactly they would turn. But what I know is at negative 3, it's going to act like a quadratic. It's going to act in a quadratic fashion. And so what we could see here, and then at negative or at 1, it's going to act like a linear fashion. And so I could draw a dotted line here through negative 1, and our graph is going to act in that linear fashion right here. And then at where x equals negative 3, it's going to react in more of a quadratic fashion. You know, quadratics look, like this. And so we can use that to kind of analyze how this will go. And so, we can use that when we make our turning points of our graph and see how it has 2 turning points, boop and boop. And so that is just another tool to help us look at how graphs will be shaped when we're trying to graph big polynomials. Again, if this last part's what confused you, don't worry about it. I'll see you guys tomorrow. Goodbye.